Okay, right. We will have to do a deeper dive on mechanism of breakdown of gases. Why? Because depending on how you read and comprehend, it's easy to get lost. Okay, now mind you, this is the introduction. If you get lost with just the introduction, I mean, then obviously continuing moving forward, it's a hopeless case. So let's just provide. Let's see if we can provide greater clarity. Okay, right. So our approach is going to sort of be a graphical approach. Okay, sort of. Yeah, so let's hope that's an appropriate approach, and let's hope it's helpful. Okay, so what I'm going to do is I'm just going to read, and then hopefully we'll be able to create clarity on what we read. So here goes now. At normal temperature and pressure, simply meaning normal temperature, normal pressure. What is that? That it is a description of the environment, meaning the habitat, the ecosystem within which we are operating. So how do we describe that? We describe that by looking at two things: the pressure as well as the temperature. It is what? Both normal. Okay, that's sorted. Our gases. Now, gases is basically the thing that we are now looking at as an insulator. So we want to know, as an insulator, gas, how is your performance? We want to rate your performance. The performance of gas as an insulator in an environment where the temperature and the pressure, it is what? Normal. So, okay, right. So what is our conclusion? Our conclusion is that it's an excellent insulator. But now, being mindful of that, let's move forward. Okay, the current conduction. Now when we talk about current conduction, what exactly are we referring to now? The thing that we are referring to now is our current conduction, simply meaning our ability to conduct current. Now I want us to look at that as a for now, let's call it density function. Let's call it a density function. Simply meaning, what do I mean when I say density function? Density function simply meaning we are going to look at current in the vicinity of surface area, and the higher the current within the vicinity of that area, simply meaning the area is going to be what? Limited. When we say limited, it's going to be what? Centimeter squared. Okay, centimeter what? Squared. So that's the area within which we are limiting ourselves. Okay, and now we are looking at the current being conducted in that unit of area. That's why I am referring to this as a what? Density function. Okay, so when we look at that now, here we managed to draw our area. So it's centimeter by centimeter. And now we are going to look at the, for now, let's call it current population or current conduction, meaning our ability to conduct current within that unit of area. What do we know about that? We know that it is what? Small. It's very small. It's something like 10 to the power of negative 10. That's an incredibly small unit of current. Okay, so a more accurate way to depict it will be to say we have this surface area here and a very small region in that surface area is used for what? For current conduction. So simply meaning we have a unit of area and a very small fraction of that surface area is used to do what? To conduct current. So simply meaning, yes, we can conduct current, but a very small unit of that area. This should just give us perspective. This could have been meters squared. This could have been millimeters squared, but in this case, we are using centimeter, okay, squared, and then with reference to that centimeter squared, we just want to gain perspective. And the perspective that we are gaining is that the current being conducted in that area, it's very small. That's why we drew a arrow here to show that it's very small, meaning it's tiny. Okay, now also, what can we say? We can say that it is small. Why? It's small, but mindful. Be mindful of the following there. It is small because of something called ionization of air by cosmic radiation. But before we get to that part, let's read. Nah? Let's read. Nah? The current conduction is of the order of 10 to the power of negative 10 amps per meter squared. Okay, this current conduction results, simply meaning the ability to conduct current. Why does that ability, why does it exist? Where does it stem from? Why is it possible to conduct current? It's possible because of ionization of air by the cosmic radiation and the radioactive substances present in the atmosphere and the earth. So simply meaning our ability to conduct current, that very small unit of current, it's possible because of ionization of air by cosmic radiation that comes from space, also radioactive substances present in the atmosphere and the earth. So now we understand why this phenomena is possible. Okay, now let's continue reading. Let's continue reading. At higher fields, simply meaning if we now change our environment, okay, if we change our environment, how do we change our environment? We can change our environment by doing what? By introducing higher fields. When we say higher fields, for now, let's take an electric field as an example. Okay, let's read. At higher fields, charged particles may gain sufficient energy. Let's do this. Right. So let's say at higher fields, okay? So here you have a higher field. What is happening? What is happening is you have charged particles. For now, let's use positive charged particles, okay? Your charged particles, they gain higher energy from what? From collisions. So simply meaning you introduce a higher field. Now in this higher field, you have charged particles. It doesn't matter. It can be positive, negative. We don't care. We just need to know they are charged for now. Okay. What we can say is that a process of gaining energy will happen. However, this gaining of energy, where will it come from? It will come from where? From collisions. Collisions with, simply, I mean, if you are colliding, you have to collide with something. Okay. What is an accident? An accident, it's when a minimum of at least two entities try to occupy the same space. That is what constitutes a collision, okay? So in this case, you have a charged particle colliding with, for now, let's call it a neutral molecule. And these things, they are colliding where? Within the parameters of what constitutes as higher fields. Meaning there's a field, and inside this field you have your charged particles colliding with your neutral atoms, your neutral molecules, okay? And it's causing ionization. Now when we talk about ionization, it means there's now neutral molecules that are no longer neutral because they collided with particles that are charged, so then they themselves now become charged, and that is the process of ionization. It's based on the impact with neutral molecules. That collision, that's where the impact comes from, okay? Now, kindly note, kinetic energy is supplied by what? The electric field. Kinetic energy, it speaks of what? It speaks of motion. So there's a motion component, a motion element. Okay, let me just try and get this page. So again, hopefully this will now make more sense. At higher fields, charged particles may gain sufficient energy between collisions to cause ionization on impact with neutral molecules. It is known that during an elastic collision, an electron loses little energy and rapidly builds up its kinetic energy, which is supplied by an external field, which we've pointed out. On the other hand, during elastic collisions, a large part of the kinetic energy is transformed into potential energy by ionizing the molecule struck by the electron. So what do we know? Our charged particles are electrons, and they collide with our neutral molecules, and that is the process of ionization. Now listen to this. Ionization by electron impact, simply meaning your neutral molecules becoming charged because they now engage with negatively charged electrons. What then happens? That impact under a strong enough electric field. This now is the most important process, simply meaning just the process of these collisions happening due to this higher field. What then happens? It's a process, and the playing out of this process, it is leading to breakdown of gases. So now we know why gases have a breakdown.